So what are we saying? We are saying that when you want to run a normality test, the first thing that you do is you need to go to your analyze, you take descriptive, you go to explore, and when you get to explore, you need to check where you have your variables, and inside these variables you must have what you wanted to test. Let's say we wanted to test for normality as far as this academic performance is concerned. We have to click on academic performance and we send it to the dependent list. When you have done this, you go to statistics. Make sure that the statistic descriptive is checked, automatically is checked. You continue. If you go to plots, then check on histogram. We don't want the leaf and the stem and leaf. You go to check the normality plot with test. Okay, then you take continue. You can now come and say okay. Now when you say okay, the first table that comes up, if you are processing summary, which indicates what you have been testing for its normality, which is academic performance. It looks at the number of cases involved, which is 107, which is 100%. There was no missing value. Now there is a statistic or the descriptive statistic table here. The descriptives are here. You can have your mean, variance, standard deviation, mix, minimum, maximum, everything. You have it there. So the mean here is 2 point something, the median is 3 point something, the standard deviation 0.6 something, the range 3 something. Now when just from looking at the mean, the median, the standard deviation, the range, you can already see that this is not a normal distribution, because if this distribution was normal, you see that the mean will always revolve around what, where you have the median. We could still go and even take the no, the mode cannot work here because we are looking at continuous data. Now so you look at the range, look at the variation that the range has from the mean, look at the variation that the mean has from the median. Just these two can already tell you that it is not a normal distribution, because with a normal distribution the mean, median and mode are always in the same area. But when you see deviation like this, just know that it is not a normal distribution. And here is the kurtosis and the skewness and kurtosis. We already agreed that when the statistics and the standard deviation are less than positive or minus 2 or 0.2, it shows directly that there is a normality. But when they are more than, like in this case, it shows that there is no normality. Then we look at the test for normality itself, where we will be looking at KS and Shapiro. We discovered that from what I mentioned, when the significant level is greater than 0.05, you have to conclude that there is normality. But when you see that when the significant level is less than 0.05, it means there is no normality. And in this case, the significant level is less than 0.01. Here is less than 0.01. So all of these are less than 0.05. Hence, there is no normality. When you come down to the graphical part of it, you discover that the histogram is the first. For histogram to show a normality, it must be such that the bars are gradually rising to the top and falling to the ends, and that the tallest bars or bar should be in the middle, and that if you have to draw a curve around it, it will surely give you what, a bear-like shape. But this is not the case here. When you look at the values, they are not rising consistently to the top. When you see a rising bar, you see another one falls, rising, another one falls, with different, in fact there are segments in it. So when you also look at how the center is, you discover that the highest bar is not obviously with the highest bars. The highest bar is instead with the lowest bars, so it concludes that there is no normality. Now you go to the next one, which is the cure-to-cure plot. That's quantile-to-quantile plot. I told you that when you see that points are too much concentrating in one area and along the diagonal line, it is showing for normality. But look at the way points are sparsely distributed. They are not close to each other. Of course, there are some along the diagonal line, but some are deviating from the diagonal line, showing that there is no normality. Now, this is also showing the same thing, because the plot to plot, the cure to cure plot, it has two ways. There could be a line that is sleeping, or that is leaning, and then a straight vertical horizontal line. So look at the way these plots are scattered from the diagonal line and not even close to each other. So it actually showing that this is abnormal, so it is not a normal distribution. And finally, we come to our box plot. Look at where the points for the box plot are. Look at where the center of the box plot is, but look at where the points are deviating from each other. They are not close to each other, and therefore, look at up here, there is nothing there. Concentrating in one side of the box plot, indicating that there is no normality. So all of these tests have proven that there is no, that this distribution is not normal. Okay, any question so far? All right, if there is no question, then I'm announcing that tomorrow we are going to begin with descriptive statistics. This is the most important part.